Okay, so good afternoon, everyone. Welcome to this NITheCS webinar. My name is Francesco Petruccione, and I'm the NITheCS director. Yeah, and today's webinar is the first in a new series that we want to start. Yeah, that we decided to call the NITheCS Micro-school. You know, we have already mini school that happen every month. Yeah. Except this month, yeah, and they're devoted. Usually, it's a series of 4, sometimes 5 lectures on the same topic. Yeah, that's why it's called a mini school. And the micro school is now a slightly different concept. We have more shorter lectures, maybe 15 minutes, 20 minutes, just to introduce some tool, yeah, some skill, yeah. And the first skill that many people need, yeah, is how to plot the data that you produce during your research. Yeah? And Donovan Slabbert, who is a PhD student in Stellenbosch. In fact, he's doing his PhD in my research group. And the topic of his PhD is machine learning with quantum computer, in particular to analyze astrophysical data from the SKA, for instance. And Donovan studied in Pretoria, but did his master's at Wits, and now he's doing his PhD in Stellenbosch. And Donovan kindly agreed to give us the first micro school on an introduction to Matplotlib, which is one of the standard tools to produce graphs. Yeah, and I like very much the subtitle of his presentation, which is "Don't Lose the Plot." Yeah. So Donovan, if you are ready, you are welcome to start, and all the participants are welcome to ask questions using the Q&A. And maybe after Donovan's presentation, we can also give you the right to speak, and you can ask your question in person. Donovan, you're welcome to start.
Yeah, okay. So I have a notebook prepared that I want to open, but for some reason, you know how these things go, it doesn't want to work on the day. So, but all I'll say for the moment is that there are many different plotting softwares available out there, many different tools. I've always chosen Matplotlib just because that's the one I got used to in undergrad. Kind of kept going with it ever since. And you can do many powerful things with it, but today I'll only be focusing on some of the most fundamental concepts for plotting a simple line plot and a scatter plot. Scatter plot being one that has just the data points themselves, and a line plot being the one that connects the points together. If I can just get the notebook open. Let's close this one. Okay. I even have a thing called Google Colab open here just in case, but not listening to me. She'll be there shortly, hopefully. Yeah, I have to apologize for the delay. I did think I was completely prepared, but for some reason, you know how it goes.
Don't worry, take your time.
Okay, there we go. All right. Okay, so for those who don't know, this is called a Jupyter Notebook. It's a form of using Python. There are many other ways to use Python. This is the way.
Donovan, sorry, we don't
Yes.
see anything. You don't share anything.
Oh, of course not. Yeah, let me give me a sec. Am I still in the meeting room? I am. Share screen. Entire screen current tab. This one. Cool. There we go. Does that work?
Yes, now we are in
Okay,
business. Thank
perfect. All right. So there are two ways that I commonly use for notebooks, specifically Jupyter notebooks. One is Anaconda, the Anaconda Navigator, and the other one is Google Colab. Google Colab is a thing where you can run a notebook like this using Python on the cloud instead of on your machine. Okay, so this is going to take roughly about 15 to 25 minutes, depending on how fast we go. And there are two main goals. To introduce you to Matplotlib and show you how to make informative plots. And the rest of the talk will be just a quick showcase of the types of plotting you get, the different types of plots, how you can, there are two different ways that you can do plots as well. We'll cover quickly. Just a quick disclaimer. I'm going to read this. Matplotlib works with many data structures such as tensors, data frames, and lists. Those are all different kinds of structures that if you don't know about that, don't worry. For the purposes of this tutorial, we will only be considering NumPy arrays. There will be a NumPy version of this talk eventually, I think next week. So if you don't know much about NumPy, then that will be the best place for it. And then all of the examples, well, some of the examples taken in this notebook are directly taken from Matplotlib's documentation. So if you are interested, please go visit this because this will also help you do Matplotlib, get you introduced to Matplotlib and all the different kinds of plotting that you can do. Okay. To use Matplotlib, or in fact, any Python library, you have to import them, right? And so here we import NumPy and Matplotlib, and this as command basically says that we'll be using the command np dot and then a command. So that's Python scripting. Okay, this is not technically what I'm supposed to talk about, but I'm keeping it as basic as possible. So whenever we refer to the NumPy library, we'll use np dot, and whenever we refer to the Matplotlib Pyplot module, we'll use plt dot. Okay, anyway, so here we go. 2D plots, the necessary NumPy commands that we'll be using is converting a list, another data structure, into an array. And then these two things, which we'll be using only for data generation, linspace and arange, they both take in 3 arguments, the start and finish of your supposed data that you want. And then the linspace takes the amount of data points. The arange takes the amount of steps you want to reach from start to finish. I mostly use linspace, specifying the amount of data points that I want in my domain of my plot. Okay, and then we have the NumPy versions of pi and the exponential function. Okay, this is really basic NumPy commands. Don't worry too much about that if you don't understand, but we are going to use them. Okay, so scatter and line plots, right? So the most basic form to plot something is just to call the Matplotlib module and say plt.plot. And you put in a x and a y argument, where x is your domain and y is the function value at those points. So again, I have x being the linspace from 0 to 8 times the NumPy version of pi, and I want 1,000 data points. And I just plot that, and there you go. There's a plot. So that's the simplest way to get a plot. But obviously, this is very... Also, just this note here that x and y should be the same length, really important. Otherwise, it can't match the points, right? Okay, so we're done, right? But now we would like to improve this or make it a bit more informative, or put some annotations on some labels or something, you know, to make it look nicer. And that we could do that, right? So we might not like the size, so we say plt.figure. What this line does is it initializes a figure object, and you want to now work inside this figure object, and you can specify as an argument the fig size, where 8 is the width and 4 is now the height here, right? Here's the plotting line again. We can add a grid by saying plt.grid equal true, right? And we could use this command plt show to actually show the plot. You don't need this for one plot, but I'll show you now why you would maybe sometimes want to put it down. So there you go. Now you have the same plot, but now you have a grid here, right? Let me just show you this. So if I were to say plt.plot and plt.plot again, and I make the second one, let's say color equals red. Let's hope that goes. This should only plot the second one. That's why you would want this plt.show. So what you would typically do is you wanted to show both of these plots in the same from the same cell. You would essentially put plt.show below both command lines, right? I hope Matplotlib works in here. Come on. All right, now it should work. Again, notebook coding, make sure you run the cells above, get the variables defined. Don't know if you know much about that, but that's really important. So see, now we've defined the X and the Y domain by running the previous line. We've plotted two plots, but only the second one shows. So now if I go and I put a plt.show below both of them, like so, it will show both. It should show both, at least. There we go, the blue and the red one. Okay. All right, so that's a way of complicated. We can take this even further. Okay, we could now plot a scatter plot instead. So now instead of saying plot for a line plot, you say scatter for the points, and this will look like this, right? And these plots, so plt.plot and plt.scatter, both have many different arguments, and some arguments that you can see here are changing the marker style, changing the color as we just did, changing the size of these points, putting an edge color. So every dot has a face color and an edge color. You can change the outline of each dot if you wanted to. You could change alpha, which is the transparency of the dot as well. So if, a value of 1 would be completely opaque. A value of 0 would be completely transparent. So it wouldn't even be there. So we could quickly run through these commands and you'll see what I mean. Unfortunately, this collabs, so it takes a bit longer. But there, we've just changed the dots to plus signs. And we could do this with an X as well, right? So there are many different things you could do. And these arguments there are arguments like this for all the different kind of plots that you get. We could run a scatter plot as a red color, like we did before. Yeah, so there's many different things we can make. We can make the dots massive. You get the point. Okay. All right, so we could make this even better, right? We could add an annotation, we could add a label to the plot and put that into a legend, the legend being denoting which line represents which plot, right? We could add an annotation. So this annotation is a bit complicated, but essentially it takes in the annotation that we want to put in, the text, its position for where the arrow needs to go, the position for where the text needs to hover inside of the plane of the plot, and a dictionary, which is another data structure, which is a bit complicated, which gives the colors and the styles of the arrow in question. Okay, you'll see that just now. We can give X and Y axis labels. So if you were to plot position versus time, the Y axis would be position, the other one would be time, etc. We could limit the domain and range of the plot. So we want to do only one wavelength or one period of the graph. We do 0 to 2 pi only. And we know that sine graphs, the one we've plotted so far, only ranges from -1 to 1. So if we go to -1.5 to 1.5, that won't affect the data, but it will affect the size of the graph that we want to look at. Okay, this is not important for the sine graph specifically, but you might need to do that, right? Then we could alter the ticks. The ticks are the individual elements on the X and the Y axis denoting the data, right? So you could have 5 ticks, like in my case here. For the Y, I have one at -1, 0.5, and then the others, right? So we only have 5 values that we are going to plot, and 5 on the Y axis, on the X axis as well. 1, 2, 3, 4, 5. Yes. So it's going to be 0, 180, and 360 degrees, and then 90 and 270 degrees. And then we have here another argument, which these all are in list form, by the way. Again, data structures, these things can take in either one value as a singular value or normally lists. It's a bit complicated, I guess. But essentially, the difference between this one and the one on the right, the one on the left, is the position of the ticks, and the one on the right is the labels we want. This R, quotation mark and dollar signs, is a way of specifying LaTeX. LaTeX is a way of writing mathematical script in code form. This is important for overleaf and markdown, as in this notebook. Markdown is a form of writing mathematical script. Again, there will be another version of this talk on LaTeX as well, if you're interested. So essentially all this is saying is, please let me write in LaTeX. In the dollar signs is what I want in mathematical script, and or the string I want, and then the dollar signs is basically saying, in the dollar signs, I want that to be mathematical script. And then you can do all of this fancy stuff. The frac command just means give me a fraction, so it's going to put 1/2 in a typical fraction. And you'll see what that looks like just now. And then as usual, we have the grid. We have a title line even. PLT title is title. We could change this to sign. And then we want to show the legend. And this legend takes the label from here and the color of this plot and plots a legend somewhere that it thinks fits well. And if we run this, you get this. So now you have the title, we have the y-axis, the x-axis labels, we have the ticks at specific lines, we have the ticks on the x-axis as well, the grid follows them, and we have the legend here. You could move this legend around, but normally the built-in optimizer for the location is pretty good at doing this for you. Okay, so this is looking ever better, right? Well, we can do even more, right? So we can go and we could use something called a fill-between plot to color in the area under the curve, or rather between the curve and 0 for some reason. You might want to do this. And so this fill-between takes into its arguments, again, the x and the y data that we have, and then some statement that we want to be true, that we want to color in. So the two cases would be where y, the data points, the y functional values, are larger or equal to 0, and for the other one where they are less than 0. So this means larger than 0 and less than 0, right? So we want to color in this area. Okay. We can give it a color as we did before, where we specified the color of the plot to be red. Now we specify it to be light coral and light blue, and we give it some transparency so it doesn't look too sore to the eye, I guess. Okay. We have an annotation again. We have the labels, the limits, the x ticks, the y ticks, the grid, the title, etc. And this is what it looks like. So now you have this little sign graph, and we've colored in nicely the area below and above the curve, depending on the values of y. Okay, we can complicate this even more. We could do something like this, right? So this is called a color bar on the right, and the points are now normalized to their y values. I don't know, you wouldn't do this for a sign graph maybe, but you might do this for something else. And so how you do this is you plot a scatter plot, again, with the x and y values to plot the plot actually. Then you specify a color argument that is equal to the functional values of the data, so the y points. And you can specify a color map, cool. Now the color map is the thing that ranges from this light blue to pink color, right? We add a label as per usual for the legend. We specify the size as we've seen. And in this vmin and vmax arguments specifically state that the color bar shouldn't go past the values of -1 and 1. Why? Because the sign graph doesn't go past -1 and 1, specifically the y values, right? So now we've plotted a scatter plot, and it will follow the typical sign pattern, but it will normalize the colors of each to its functional value. That's how this happens. And then to put this on the side, we can plot a color bar. This is this one, plt.color bar, and we need to give it a label, and that label would be the y value or the functional value, and that is what appears here. All right, so this is how you can really complicate the plots. Okay, you can do even more, but we'll stop there, I think. Now onto the second form of plotting within Matplotlib. It's AX plotting. So there are two different types. We have this plt.plot, which is they call it an implicit way of plotting. It's simple, it's quick, and it's usually done for one plot. You can do multiple, like I've shown, but usually this is done for only one. If you wanted to do multiple plots, or you needed some sort of more explicit control of the axes or the figure object, you would use AX. Most people who use this typically tend to gravitate towards AX plotting. Okay, now let me show you how this works. So remember how here we need to specify a figure object. We don't have to do this, but we can. And then from this, we can do all of this nice stuff. You can do the same for AX, where you now specify the figure object and its axis as a separate object. And you now have this subplots command that essentially will initialize multiple subplots if you were so to choose. In the current example, there will only be one case, okay? So again, we have the same x and the y as before, but we'll add the second functional values, a second function, and this will just be the exponential function of x divided by 8 pi, all minus 3/2. Okay, not important why I chose this, but essentially we're going to plot two different plots. Okay, so the first one, we initialize the figure and axes with this subplots. We specify a fig size that we want, and then we just say AX plot. So now we're using the axes to plot, not the figure object. And we have all the same arguments as per usual. And then we just say plot show, because we want to show the entire figure, right? I don't think this is necessary for just one plot, but you might want to use it if you have multiple. And this looks like this. So the same sign graph we've seen. Okay. Then another case you could do is you could do AX plot and AX plot again. And this, I think you saw it already, but this will cause the two plots, the sine graph and the EXP graph, to be on the same axes. Why? Because they are on the same axis object. And we now add a legend because there's a label here. And if I scroll down, you'll see the output is two graphs on the same Cartesian plane with a label. Really simple. Okay. We can also instead do side by side of the same two. So now instead of only doing a figure and one axis object, we can initialize two axes like this. And now in the subplots command, we say we want two figures in one row. So one row, two columns. And we specify the overall global fig size, which is 12.3 now because this was 6.3 to keep the same sizes, right? So now two graphs next to each other will be twice the size. And now we do AX1 plot and AX2 plot with their own grids, and we show the entire object, and that has this effect. So now we have two on separate plots. Okay, and you can go even further by saying, okay, what if we did 4 axes, 2 rows, 2 columns? We make the fig size even bigger, and we have all the axis objects. And now we plot 1 for X1, 1 for X2. We have 2 for X3 at blue and purple, and we have 2 for X4, but we swap the colors around. It's very simple. Then you have this object at the bottom here, where we have the 4 cases of plotting. So if you had, like, let's say you had 5 different plots that you wanted to plot, and 2 had to go on the same Cartesian plane, this is how you would do it using AX plotting. And this has the same functionality as plt.plot as well. Okay, that's pretty much all that needs saying, apart from one little final part, which is saving a data plot, which is for PLT, you just say save fig. And this, when you run this line, it will save the plot, this image, as a PNG, or you could do an SVG, which is a vector format, or a PDF. You can do all of that. And when you do this, it will save within the directory that you work in. So wherever this Jupyter notebook is in your laptop or online, you can specify the path folder if you did want to, but I don't ever do that. And you can do the same for AX plotting by essentially save as, yeah, it's the same command really. Okay, that's all I think from my side. I hope that was understandable.
Yeah, no, Donovan, thank you very much. It was really very nice. I enjoyed very, very, very much. Yeah. Are there questions for Donovan? And please, you can raise your hand, and I can give you the right to speak, or you can use the Q&A. Yeah, we want to try to keep it a little bit interactive. Yeah, And I just shared with you a little poll for feedback. Yeah, because this is a new initiative, and we would really appreciate if you could give us some indication of how we can move forward. Yeah. Yeah, there's a question, sorry, about the recording. Yes, we recorded the session, and we will put them all on the NITheCS YouTube channel. Yeah, if you go probably tomorrow on the NITheCS website, you will find the link to the YouTube video of the lecture. And I'm sure Donovan will share the notebook with us, and we can upload the notebook as well. Yeah, so that everybody can have a good starting point for many plots. Yeah.
I just forgot. I wanted to scroll down, just showing you all the different kind of plots you can do, by the way. So we have things, fill between you've seen. This is a different kind of fill between where we could do some error analysis. We have vertical stack plots. We have histograms and bar plots. We have horizontal bar plots, error bar plots. We have three-dimensional surface and tri-surf plots, scatter plots, you name it. There are many different kind of plots you can work from, even these geospatial stuff. They are all on the website on Matplotlib's documentation. If you want to just go through that and see how this works, you can. Okay.
Yes, but we will probably plan, this was the introduction to Matplotlib. We will plan other micro schools on intermediate and advanced Matplotlib skills in the near future. Yeah. Any question for Donovan? Donovan, I think your lecture was very, very clear. Nobody wants to ask any question. People are clapping, and there are lots of compliments in the chat. And please take a second to fill out the feedback, because the more accurate the feedback is, the better we can plan events like this in the future. Yeah. Okay. Then thank you very much. Next week, we have another micro school, again, Wednesday at 2 p.m. And I think that is about Visual Studio Code. Yeah, an introduction on how to use Visual Studio Code. Yeah, but we will share the announcement very, very, very soon. Yep. Okay, wonderful. Thank you very much. I hope to see you all next week again. And if you have suggestions for other mini school, please don't be shy. Drop us an email and let us know. Yeah. Thank you very much. Thank you. All the best.
Thank you.
Bye. Thank you, Donovan. Thank you very much. It was really very nice.